Okay, here's your homework. 8 problems, 8 equations, and inequalities. So actually, 4 inequalities. No, I'm sorry, 4 equations and 4 inequalities. 1 through 4 is review, what we've been doing this week. 5 is a little different, but you'll see it's not that much different. 6, 7, and 8 are a review from last year. I know it's been a long time. So I'll go over one of these with you, and hopefully from that explanation you'll be able to do the other two. So make sure and try them before you look at the answers. And the other ones that I don't go over, feel free to look around the internet if you need some help, if there's something you can't remember. Go around and see if you can remember, because everything here, except maybe number 5, which we have not talked about, and I don't know if you talked about last year, everything else is something that you are capable of doing that you should have seen at some point this year or last year, definitely. All right, so try these problems. Okay, looking at number 1. All right, it's, remember, you want to get the absolute value function or part of it all by itself. So we want to subtract 10 on both sides. And we're going to have the absolute value of 3x divided by 2 plus all that plus 2 equals 11. All right, from here I'm going to set up my 2 equations. So for the first one, I'm just going to take away the absolute value, 3x over 2 plus 2 is equal to 11. That's my first equation. My second one will be the negative parentheses 3x over 2 plus 2 equals 11. At this point, you might not do the step with the parentheses. You might just say, okay, I know that the other side has to be negative, and so you can go ahead and do that. All right, so I'm going to do the first equation. So I have 2 of them, 1, 2. I'm going to subtract 2 here. And I'm going to end up with 3x over 2 is equal to 9. Now in this case, the 3x is being divided by 2, so the opposite of that, one way we can do it is just to multiply by 2 on both sides. When we multiply, this is just going to cancel out, that 2 and that 2, so you'd have 3x. If you did not cancel it out, you'd get 6x divided by 2, which would still reduce to 3x. So 3x equals 18 divided by 3, and we have x equals 6. Remember, we're going to want to check this, but right now we think 6 is the solution. Here, I'm going to divide by -1. We're going to get 3x over 2 plus 2 equals -11. All right, still going to subtract 2. This time, instead of the 9, you're going to end up with 3x over 2 is equal to -13. So, same thing as on the first equation, multiply both sides by 2, and that is going to effectively cancel that 2. We get 1 times 3x, which is 3x, is equal to -26. Then we divide by 3, and we get x is equal to -26 all over 3, and that cannot reduce. And in order to do the check, you don't want to put that as a decimal, because the check won't work, especially when you have a denominator of 3. And don't want to talk too much about that, but I'm going to check this with it in fraction form. So I'm going to check both of these answers. So to check them, I'm going to plug them back into my original equation. So my first value was 6. So let's try 6. So I'm going to just do it right here. 3 times 6, so that's the absolute value of 18 over 2 plus 2, then plus 10 is all equal to 21. And 18 over 2 is 9 plus 2, absolute value plus 10 equals 21. 11, absolute value plus 10 is equal to 21. And 11 plus 20 plus 10 equals 21. That is a check because 21 is equal to 21. All right, so that's a check. So our 6 works. And I'm going to try negative 26 over 3. This will be a little bit more work. So I'm going to have 3. Our x, remember, we're thinking is negative 26 over 3. And all of that was still over 2. Plus 2. Then plus 10 is equal to 21. 21. All right, so on the inside, we need to deal with this top part first. So top part, right here. Then I'm about to put a mark in blue. That part right there. We need to deal with that part first. So just to the side, I'm going to just think to myself, well, how would I do 3 times negative 26 over 3? Well, remember, 3 is just going to be over 1. So you could multiply the tops, and you'd get negative, what is that, 20 times 3, that'd be negative 78 all over 3. But if you know, and then you can reduce this, but you might not notice that 3 can go into 78. What you could have done at the very beginning is notice that these cancel. So we actually end up with just negative 26 over 1. So negative 26. So I'm going to go back here. So this entire thing is just going to be negative 26. Remember, that's still over this 2, so don't forget about that 2. So plus 2. Absolute value plus 10 is equal to 21. And then I have negative 26 divided by 2. I have to still do what's inside the absolute value. So negative 13 plus 2. And then all of that plus 10 is equal to 21. Negative 13 plus 2 is negative 11. Plus 10 is equal to 21. Remember, the absolute value of negative 11 is 11, so 11 plus 10 is equal to 21, and that checks out because 21 is equal to 21. So we're good. So that is number 1. Okay, this is number 5. We haven't looked at one like this. It's actually a compound inequality, but it's no different than the ones we've been doing, except we're going to have to set up 2 different equations. 2 sets of equations, which will actually be 4 equations. So this is what I want to do. We're going to look at this 2 separate ways. First, we're going to look at it and imagine covering the right part of this inequality. So I'm just going to cover that. All right? So now we have this right here on the left, and that's going to be 6 is less than x plus 1. This is still the same as we've been doing. You're used to seeing the absolute value on the left. It doesn't have to be on the left, so that's okay. Now I'm going to take this, move it over here. Now we're going to look at it from this perspective. We're going to have x plus 1 absolute value is less than 8. Okay, now all we have now is 2 different inequalities with absolute value. That's all. It's not complicated. All right, now we're going to go ahead and solve each one of these. The absolute value already all by itself in this one. So we can go ahead and set up our 2 inequalities. So we're going to have 6 is less than. Now, you don't just want to switch this. So I know you might be tempted to put the absolute value on the left. You can do that as long as you also change the inequality. I'm just going to leave it how it is. So x plus 1. All right, so that's your first one. And then we're going to have 6 is less than x plus 1. All right, so I'm going to go ahead and solve these. So my first one's going to be subtract 1, subtract 1. And I'm going to get 5 is less than x. Now I can turn this around. This is the same as x is greater than 5, right? These are equivalent. So I can do that. All right, that's my first one. And my second one is going to be, remember you do, let's see, what I'll do here first is divide by -1, divide by -1. That means we have negative 6. Now we have to still flip the sign. X plus 1. We subtract 1, subtract 1, and we end up with negative 7 is greater than x. Alright, we can also flip that around and write that as x is less than negative 7. Those are equivalent, so it's easier to read with the x on the left. I know students always say that. So let's go. I'm going to go look at the graph on JMap, not JMap, here, and see what they put. Where's the answer here? Okay, so negative 75. All right, so that's for the first part. But again, we didn't do the second part yet, so should have probably waited to show you that. But let's just see how that happens. So now we have to do the this equation here, which is going to give us same thing. We're going to have x plus 1 is less than 8, or negative x plus 1 is less than 8. So here we subtract 1, we end up with x is less than 7. And over here we subtract, do the negative 1, do the negative 1, and we get x plus 1 is greater than negative 8. And subtract 1, and we end up with x is greater than negative 9. So there we go. Now we want to put this on a number line. These are both and statement. Let's do the left one on a number line. Matter of fact, we'll put these all on the same number line. Let's do that. So we'll make a number line. The numbers we are going to need, the lowest number looks like this negative 9. So I'm going to put negative 9 over here. The highest number it looks like we need is 7. So let's just try and make this somewhat to scale. That's good. You know, if you were to do this and you had your negative 9 here and your 7 there, I'd say okay, that's you know, you gotta at least be realistic. So that's good right there. That looks good enough. All right, so we have first one. Let's do x is greater than. Well, let me put 5 on there too, because we need 5. So 5, you know, right there. And what else do we need? We have 7. We need negative 7, which is about right here. All right, so we have our first set is x is greater than 5. X is greater than 5. And also, okay, I gotta pause this for a quick second here. Okay, came back, decided not to do that on one number line. So if you look at the number lines I have drawn right now, this one on the left, now that is just for the part of the inequality when I cover this. So if I were just to look at this part here, these are the values that would make it true. Everything less than negative 7 or greater than 5. The problem with that is that's not the entire inequality. I also have to consider what would make this true. So what would make this true is everything greater than negative 9 and less than 7. So to put this on one number line would be confusing. So what you need to try and visualize is everything 5 and above, according to this one, would work. But according to this, it's everything 7 and below. So we can put that together and say everything from 5 to 7. And then everything from negative 7 to negative 9, which might be a reason that they did not put a number line on this answer, because it gets kind of confusing. But we should be able to see why it's written this way. So that would be legitimate to write it that way. All right, so everything from -9 to -7, that just means -9, -8.99, -8, everything up to -7, and then also everything from 5 to 7. All right, so if you did want to draw a number line in that way, you could, but you'd have to go and, you'd have to look at all these numbers, and so it'd be from -9 to -7, so it'd be here, here, and then also 0 from 5 to 7. Right, those are all the values that make it true. From -9 all the way up to -7, everything in between, and then from 5 to 7, and everything. Actually, the -9 and the -7 don't actually work because you have an open circle, because it was less than, didn't have the equal sign with it. All right. These also the 5 and the 7, but everything in between. So the 5.01 would work, and so on. All right. Went a lot longer on that one than I thought I would, but hopefully you get a little. Okay, here's a quadratic equation. The reason we know it's quadratic is because the highest exponent is a 2 right there. And when you have the highest exponent on a variable as being a 2, you have a quadratic function or a quadratic equation. There are a couple of different ways. I'm doing number 8, and hopefully my explanation here will help you with 6 and 7. First thing you could try and do is factor. So if I have 3 terms when there's nothing next to the x squared, so not 0, but 1 is the coefficient of x squared, and you have 3 terms, you can think to yourself, well, is there anything that will multiply to give me -18, not negative, +18, and also add up to a -10? As I look, I don't think there are any. I'm thinking for 18, you have 6 and 3, -6 and -3, 9 and 2, -9 and -2, 18 and 1, -18, -1. None of those multiply to +18, but also add up to -10. They all multiply to +18, but none of them add up to our -10. So we don't have, this is not factorable. So we have to use a formula that will always work when you have quadratic equations. Quadratic formula. So I'm going to write that quadratic. Hopefully you remember this. Maybe you haven't memorized it, but you should at least have seen it before. It's going to be x equals -b plus or minus b squared minus 4ac all over 2a. Now, if this had been factorable, we would have set it equal to 0 and then set each of the factors equal to 0 and solved each one of them. But this formula will work for 6 and 7 also. All right, it will always work. So let's go ahead and figure out what's a. Well, a is always the number next to our x squared, which when there is none, we know that that's just 1. So a is equal to 1. B is equal to the number next to our x term, or our variable that doesn't have an exponent except for 1, and that is -10. And C is 18, the number without the variable. Now we can just go ahead and plug them in. So I'm going to have x equals negative. Now, it's the negative of -10, or the opposite of -10. So be careful with that. Plus or minus b squared. So our b is -10. Minus 4 times a, which is 1, times c, which is 18. All right? Okay, all of that over 2 times 1. Okay, so we have x equals that negative, or the opposite of -10 is just going to be 10, plus or minus. Now, -10 times -10, which is what we have in here, is a positive 100 minus 4 times 1 times 18, which is 72, I believe. um, all over 2. All right, keep going. I like to deal with what's inside of here first. So I do x equals 10 plus or minus, that's going to be 28, all over 2. All right, now I want to deal with this square root. It's not a perfect square. Remember, our perfect squares are 4 other than 1. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, that's 13, 12, 14, 196, I think. That one might be wrong off the top of my head, but the ones you really need to know are pretty much up to, I don't know. Yeah, maybe you do need to know. Maybe you do need to know up there. All right, but anyway, 28 is not a perfect square. That's the important part. Now we have to think to ourselves, remember breaking down, simplifying. Is there any perfect square that goes into 28? Well, as I look, 4 definitely goes in. So I'm going to break this down and say x equals 10 plus or minus 7 times 4. I broke that down all over 2. Now we're going to have x equals 10 plus or minus. Now remember, this 2, I'm sorry, not the 2, the 4 can come out because it's a perfect square. I could write this as radical 7 times radical 4. Remember, and the 4 would just become 2. All right, so we'll write it as 2 radical 7. All right, all over 2. And at this point, remember, you usually have 2 solutions, or sometimes you have 2 solutions. Sometimes you have 1, sometimes you have no real solutions, but in this case we have 2 real solutions. And how do you get those? Well, you write x equals 10 plus, that's where this plus or minus comes into play, plus 2 radical 7, 7, all over 2, or x equals 10 minus 2 radical 7, all over 2. All right, now these can be simplified because you have your triangle of numbers here. If they are all divisible by a number, then you can simplify them. So we have x equals 5 plus radical 7 all over just 1, right? Because the 2 divided by 2 just gives me 1, so 1 radical 7. 10 divided by 2 gives me the 5. So you probably see this just 5 plus radical 7. Or over here, same thing, x equals, and then these all, right, it's going to be 5 minus radical 7 all over 1, and typically you're going to see that as x equals 5 minus radical 7. All right, so there you go. That can work for those primes. Now in 6 and 7, I did make them so you could factor them, but you're not always going to be able to factor. Matter of fact, most of the time, you're not going to be able to factor, especially in this class. So it would be good for you to be able to use the quadratic formula and become comfortable with it. All right. Also, something that I did not talk about, whenever you're solving quadratic equations, you always want to set it equal to 0 and then put it in standard form. Now this one that we're doing, number 8, is already in standard form and it's already set equal to 0. So we don't have to move things around. But you cannot use the quadratic formula until you set it equal to 0 and also put it in order. So in other words, let me erase some of the stuff here. If this was x squared plus 18 minus 10x equals 0, this is not in standard form. All right, so I have students that would say, well, my A is 1, my B is 18. Nope, right there, they've already made it, so they're not going to be right. Your B has got to be the number, the coefficient of your x term. Your term that doesn't have an exponent other than 1. So put in standard form, set it equal to 0, then you can use the quadratic formula.